And I'm live. That is pretty cool. Today is 10th of January 2026, and I have not streamed in a while, but yeah, there was stuff, and but here I am, and let's start streaming. Just let me see. Yep, everything seems fine. Video is public and at the right place. So, yep. So, what is the thing that we are trying to build here? We are inventing evolution here. Like literally, we are going to invent evolution, and that means so the vision that is in my head is that we will have our front end. There would be no need of a back end, and in our front end, the minimum selling point is the minimum viable product is this. The user will see a bunch of organisms in a box, right, or like whatever, and those organisms would be we can decide how those organisms are going to look, but the initial thought is they will look like something like stick figures or something, and we can later on, if our organisms become more complex, we can make them have different shapes like a butterfly or something. And yeah, so we will have different organisms in different boxes, and the user will then select one of the box, let's say any box, and then we will add some random mutation to this organism, and 5, 6, 10 other organisms will be formed by adding random mutation to this organism, and we will that will be our next generation, and this process will keep on moving forward. Yep, that is the whole idea of this thing. This is very simple, and that is cool. And what we have to decide for this is how are we going to store the DNA? Not how, but what would be the things which are represented by the DNA. And this idea of evolution like this is like, of course, not original. First, this came by Charles Darwin, Mr. Darwin. But the idea that we can make this in computer, like organism evolution in computer, this was by Richard Dawkins. I heard about this by Richard Dawkins, and this seemed cool, so let's make it. Hello, shit. Yes, I forgot the password now. I remembered the password. I was able to log into my account. Yep, I think there is some new React XSS vulnerability. Cloudflare sent. Wait, they sent you a warning personally. Shit, this is crazy. DNA storing. Yes, DNA storing. DNA, but yes, of course, we will have some primitive form of DNA. And yeah, so we will have numbers. Yes, we will have numbers. We will have different numbers. Let's say there would be number, a number which will represent how many branches a certain branch is going to have, and how many layers there are going to be, and what should be the angle between these things. And yes, maybe we can even add DNA sequencing about how many middle things there are, how many like main branches there are, or if there is a branch or not at the center. Hmm. So first of all, today let's make something visual. React component which will take DNA for an organism and then show us how it is looking like. And shit, I am very stupid because I haven't coded in React, programmed in React in some times. So let's see. Our main goal for today is going to be just this something component in React which takes in DNA and yeah, takes in DNA and shows us the form. So we have to decide the DNA, like yeah, we have to decide DNA. We are going to be gods today, and React component to make an organism with the DNA. just that. So yep, that is kind of cool. Decide DNA replication, and instead of, we will not have natural selection in the final product. The user, the person who is playing this game of being God, will be the one, will be natural selection, will be acting as natural selection because they are selecting the thing. Okay, so yep, and something a cow is saying evolution, 3D evolution, and GitHub. Yep, this will go to GitHub and onto the resume, new repository, evolution. I messed up. Uh, Git clone, evolution, and yep. How to initialize a React project. It has been quite long. So I have my website hosted there, static, of course. So they sent it. Okay, okay, from Cloudflare. So I feel like writing it in Go and serving it from Google Cloud Runs in is the best method. Okay, I don't know why you would prefer one method over the other, but I don't know. No unnecessary vulnerability, no way to be back and hacked by someone. Okay, or website won't stop working because someone removed their line 15 of line model code. Eh, Okay, well, I guess now these things are becoming more and more common and not like some one-off thing. So that is something we have to keep in mind, I guess. Okay, how to uh wait, we will use white. Yes, white. White. Yep, get started and no bun. We'll use bun, create white, evolution, TypeScript, roll down experimental, no, install with bun and start now. Yes, but I think I have one bun at global level. 5173, 73. Okay, it is working. Yep, 156, probably. Yes. Okay, a little bit messed up. CD, evolution, CD back, move everything from the evolution folder onto this current folder, and it is not moved somehow, right? Hmm. CD evolution, ls evolution. Shit, I moved everything to this folder. Okay, that is very sad. I moved everything to like the parent folder, not to the current folder, my bad. And rm rf evolution and bun create white, project name evolution. It didn't ask for all of this before. Close, is running. Cool. 7.3. Yep. Shit. Your message got deleted somehow. Lol, yeah. Yep. Yep. Messed up. Off to a great start. Yep. Uh, Move, evolution, everything here. Yes. Okay. And yep. Go to source. Yes. In the app, in the main, we are just selecting the root element and injecting or adding this single React component, which is this, yep, which we do not want. Yep, we don't want this, so we can just remove all of this assets. Here we will have a directory, components, go to components, and a component named make make.tsx make, and yeah, add this to harpoon, add this to harpoon, and both of these have been added to harpoon, the component and the main app, and we can just switch between them very quickly. That is cool. And cons make, this will take in something and do something. Wait, shit. Yes, it's my bad. Like this. JavaScript. Okay. And return make is declared, but never is. Okay, so wait, how do we export but without using, I think we can use the export keyword here. Yeah, cool. And we can import here, import dot class components slash make and render make here, not this make, import make from this should work. And h h1, this is the make component. Okay, and now we can expect to see something on the website local, or maybe not. Shit. Run, no shit, bun run dev 5173 localhost 5173 localhost. This is the make component. Let's go. So yes, it is working. Hello. React and Next.js had like 4 to 5 major vulnerabilities in the last 4 to 5 months. I didn't watch, I mean, I watched the low level video by low level person, but I don't know what those vulnerabilities were doing, or like what is the reason for them. I was making an application to be used on my phone. That is crazy. And one thing I realized was it is Android development is messed up easier than easier Then web development. I don't know how we came to this. Wait, Android development is easier? Okay, where Android is easier than web. Teams at Android have made really work their asses off to create Jetpack, compose, and move from XML. There were more he didn't cover. Ah, shit. Yes. And some of the vulnerabilities are such that even if you don't use that feature, you can still be targeted. Mm. Okay, about these vulnerabilities, I guess, I mean, we can just make websites and let others decide for the vulnerabilities. I mean, I'm not very good at web development just yet, and right now, worrying about the vulnerabilities or anything like that is like not my main priority. Kotlin and Jetpack Compose is much easier than current web. Hmm, that is cool. And I thought I would say this, but where have we come to? Yeah, things will get better. Don't worry. I hope. Okay, and okay, so this is working at least. And main.tsx, cool. Yeah, I will have to relearn or like look up everything for this. I don't even remember CSS properly, but like no one remembers CSS. I mean, there is no harm in knowing. I know that there are vulnerabilities, and that is the extent. We now have to decide on the DNA. This thing, part one. Decide on the DNA, and for which we also have to decide how we want the final thing to look like. Final organism, and it will be like a stickman, two-dimensional stickman. No three-dimensional organisms in our world. We will just have two-dimensional organisms. So yes, a stickman, and I think the blind watchmaker, evolution, images, evolution, game. Yes, this. So this is the inspiration, the original thing that I saw, and I then wanted to make this game or whatever you want to call it. So this is what Richard Dawkins created, and these are organisms that he was able to make with this game, and this is how they look like. And these are kind of stick figures with just straight lines. Hmm. And now we have to decide or think about how we can write some sequence of code or some values, some numbers. Given those numbers, draw, we can reduce any of these organisms down to those numbers. And if we have those numbers, we can then draw back the organism. So in the book, he had like some values, six, seven numbers, each with each number could have had value from 1 to 10, and each number was representing something. Like there would be a number which represents how many layers of branching there is, and a number to represent how many branches there are when a layer is branching, and numbers for angles. Hmm. So we have to decide. Okay, we will have one number for the number of layers. Yes, I think that is reasonable. So yep, we will have one number for the number of layers that the organism will have. One number, and let's say each number will have a value in a certain range. 1 to 9, let's say 1 to 9. Yep, and okay, so we will have one number for the number of layers, one number for the number of layers, and number of branching is some. At the end, what we need is something, some numbers which we can reduce any of these shapes down to. So number of layers, number of branching, but we cannot just have one number for branching because different layers here seem to be branching at different angles or like different numbers. Hmm. Branching, we can have a number for the number of base branching and then a second number which tells us at the end of next layer how many more branches or less branches it should have. So if we have, let's say, number of layers equal to 3 and this number like base base branch number, and let's say branch delta, how much the branches are increasing or decreasing, and base branch is let's say 1 and branch delta is 2 and number of layers is 3. So let's say we'll have a single line, we are, and this is supposed to have one branch. So let's say it has one branch on like both the sides at some angle. Then so this was layer number 1, this is layer number 2, this is layer number 2, and now for the third and the last layer we will have the number of layers, the number of branches in the last layer plus the delta, so 3, like this, 1, 2, 3, something like this. And that is our organism. Very bad looking organism. Hello, welcome back. How are you? Wait, shit, that is a lot of things. Uh, okay, tags. I use Minify to export build. What is this for? Wait, what for? Set up Tailwind, though it will increase the classes names, it will significantly much better than shit. Yes, Tailwind. Yes, I will add Tailwind to this. My bad. So, yep. And we need more numbers to have more complexity in our organism. We should have a number for the angle. We'll call it base angle, and a number for angle delta, how much the angle is changing. Okay, that is something. So let's say number of layers is 4, base branch, let's say is 2, branch delta is let's say 1, base angle, base angle. Wait, how would we measure the angle? Like if there is a single line, let's say this is the end of a branch and base angle is let's say 60-degree, what does that mean? What does 60-degree mean? I guess we can say we can arbitrarily choose one side to take as the base, and the branch will start branching off from this side, and this will be like 60 degree. And yep, so this 60 degree, and let's say we need to have three branches from this place, and the remaining angle is 300 degree. And since we want 60 degrees, we can divide this 300 into like 50 50 50, and we can make our branches. So yeah, that is how, let's say, we will interpret our angles. Yep. So base angle, let's say, is 60, and delta angle, let's say, is 30 degrees. So base branch is a single line. Let's create it with actual lines without sloppiness. Right. Base angle is 60. Okay, this is our branch number one. Layer number one. For layer number two, we need to have two branches. Two branches. Okay. And there is, let's say this is 60 degree, and the remaining would be 300 degree. And we need two branches from this place. So let's say this is approximately correct. And then this is approximately correct. And yes, we also have to decide the length of these branches. That is, we another number we can add, we should add. And we will do something similar on the opposite side. Just tilted. Yep. So we are done with our second layer, and on to the third layer. On the third layer, we base branch number will now increase to 3. So on all of these four ends, we want four branches, and the base angle is now 90. So base angle is now 90, which would be around this. This angle would be 90, and remaining angle is 270, and we need three branches in 270, that is 90 90 90. 270 by 3. So we just make something like this, straight. Shit, that is crazy, because this last branch will go back and come right here. Okay, so let me increase the size. So this angle is 90. This angle is 90, and we want three branches. One is this, one is this, and the third one is back on its parent. So yeah, it is here, and its end is here, and the next layer will start from this place. So that is something. Okay, and we just have to copy this on all of these four branch ends. Copy, paste onto this. Yep, like this, and same here. Yep, and then same here. Yeah, looks good. So we are done with our third branch, and now the last branch, which the last layer, which is going to have four branches each. And the angle now is 120. The current angle is 120. Okay, let's see. Oh, I will pass. I will like not probably not get a back. I will pass. That is fine. From vertical, make height as y-axis. Mm, No, I think instead of having a Cartesian plane, radial would be good, and we don't even need x and y axis. We can just make this like the place where we want to add a branch as our like base or something. Wait, shit. And just make branch from there. For length, for height, we can ha have something like this. We will have a base height, and then we will add and or like we will have a delta for the height, another number which will act as the delta for the height. Okay, now the angle is 120. Let's say this this from this thing, from this line, this is about 120, let's say, and we need to have four branches: 120, 360, 240, 240, 460 degrees. So let's say this is one line. Shit, I shit. Wait, if we okay, my bad. Yes. If we let's say if we at any time have some angle which we want to divide, let's say we have an angle, some random angle, and we want to add, let's say, two lines in this so that the distance is symmetric, equal. So instead of dividing this angle by 2, we should divide this by 3. And that makes more sense because when we divide this by 3, wait, let me, when we divide this by 3, we have 3 equal places, 3 equal angles, and that is the number of segments or angles we will have in total, even though the number of lines which is dividing this whole initial angle is one less than the parts. Yeah, this is how maths works. Yes, if we have a like distance d and we have two lines uh, and dividing the distance, then we will have three parts that this original distance is divided into. So shit, instead of dividing the final angle by the number of branches at that layer, we need to divide it by the number of branches plus 1. So here 240 divided by 5, that would be 48. Okay, because like in this case we got the last branch on the parent branch, and this is what we will always get if we do not divide by number of branches plus 1. So yeah, let's add one here and one here, and this is about it. We just have to copy this and paste this at different places. This and here also. This and this like this. Cool. And there must be a thing, a line here. Shit. Yep. And the same thing here. A line here. One line here. And one line here. Should look like this. Yep. Correct orientation. And yes, we are doing more biology than computer science. Yeah. One here. And the last one. Cool. And the organism is this. That is looking good actually. That is looking good than better than I thought. So that is cool. And if we change the numbers, we will have different things. And yes, two more numbers that we need to add, or we need to change the DNA is base length, and seventh would be uh, length delta. And yep, we will have shapes like this. Richard Dawkins had shapes like this. We will have shapes like this. That is cool. Let's see. And okay, so yes, we can consider this figuring out how to represent the DNA part done, or we can add some things later on. And on to the next step, a React component which takes in these numbers and then makes the organism. And this I have literally no idea how to make a shape like this. How do we make something like this in web? I think we have to use something like Canva or something, 60-degree from the vertical. Second, and center of the screen as 0, 0. Origin shift, at least that is how I usually do it, making things easier and natural to calculate. But yes, we are not adding things on a canvas with some coordinates, because like when this initial line is being made, I have no idea where this point would end up at. The only reference is where the end of the current branch is, how many layers I need to make now, and yeah, wherever the next end of the branch would be, that would be the origin to make new lines from that point. So that is a better model for this use case. Okay, how to make drawing in web dev website. That is not a very good font. ChatGPT. Okay. I need to make lines with relative shade, but this is what I think web dev is going to provide us. And shade, yes, I think this is what web dev is going to provide us. I did watch a TS Oding video. He was doing something. Yes, this is what web dev will give us. Canva with Cartesian coordinate system, and we will have to have some inner functions, some translation layer, which will convert all of this into the Cartesian plane and then tell the browser to draw it. How to make lines and things with angles in a website, in a website with React. There might be a React library. And no, divs alone won't scale. Yes, divs won't scale. The core problem, child W, no hand waving. A browser page is basically a stack of rectangles, angles, as that angles are not rectangles. So every solution is a workaround. SVG, SVG, we can create a SVG. SVG, the correct answer most of the time. SVG is literally made of this lines, angles, vectors, rotations, transformations. We can do this. We can do this. We can make a SVG example, React plus SVG. Line starts at this location, stroke black, stroke width. We can make a SVG, I think. Shit, yes, we can actually make a SVG. Let's see. Yes, we have a line. We have a line using SVG. Hmm. Do we want this? Do we want this? This can work. This can work. Using SVG can work. We will make a central line at some point, and we can keep adding layer by layer all the new endpoints, and we will have all of these updated values for the next layer, and we will make new endpoints and just keep cycling through them in a DFS kind of manner, and that would work. That would work. Okay, let's do that and also look at some other options. CSS transformation, no. Canva, powerful but heavy. CDX, Canva ref, line 2, this thing. Hmm. We can use SVG or we can use Canvas when Canvas makes sense. Games, how, okay, our lines are not moving, so that is one thing. Physics simulation, no, we do not need that. Real-time animation, no, we do not need that. Why it is a overkill for websites? No DOM elements, harder interactivity. You must track everything yourself. Canvas is a paintbrush. SVG is blueprints. I think SVG is better. SVG is better. So what we need is a function that gives us a SVG. Wait, but how do we define the final thing? Wait, at the end, we can reduce our whole figure into lines. These are just lines with some ending and starting points. That is all this is. Just some lines. So we can have a React function which takes in these numbers and gives us at the end these lines. Let's add one more number for the thickness of the lines. Base thickness and ninth number thickness delta. Okay, that looks good. 9 numbers. So we will have a React function. We now will make a React function that takes in these numbers and gives us lines. And in a SVG, we need color. We do not need to add that. Will might, yeah, we can add. Think about color later. Width, start, and end point. Yep, a function that will return all of these lines as a list. Okay, let's assets, no, helper, make svg dot TS TypeScript const make SVG, and this will take in a list of numbers. Long time since I coded in JavaScript. Export, and we need some place to store all of these template kind of things. I guess we can just do it here. Interfaces. Oh, shit. Interfaces, and yes, and let's say DNA dot ts export DNA. Wait, how do we write our interface? Interface DNA is our interface. Uh, write an interface in TypeScript. Interface user this. Okay, we see some updates in Vim. Synchronize. Okay, interface DNA is declared but never used. It will be outside. Okay, and our interface looks like this. So we have layers, an integer. How 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 do we do this? String number. Yeah, okay. Layers is number, and base, or let's say branch, branches, branches, number, del branches is a number, snake case. Wait, yes, wait, I don't know, snake or camel. Del branches, and angles is a number, del angles is a number, and then we have length is a number, and del length is a number, and thickness is a number, and del length is a number. Del thickness. Del thickness is a number, but that seems good enough. And our helper function here, import DNA from this place, and let's say our function here takes in DNA of type DNA. DNA is a type and must be imported using type only when import DNA. DNA is a type and must be imported as type only. How to import interface in TypeScript? Export. Shit. Okay, this is exactly what we do. Export this thing here and then import. Here we are exporting DNA and here we are importing DNA, but there is some problem. DNA using a type only import verbatim modular syntax is enabled. When verbatim modular syntax is enabled, so I guess is some setting we can change. It is not a linting thing. T is config, I think. Uh, yes, verbatim modular syntax is true. What is verbatim modular syntax? Let's see. Uh, verbatim modular syntax. By default, TypeScript does something called import Elysian. Elysian. Basically, if you write something like this, okay, TypeScript detects that you are only using an input for types and drops the import entirely. Your output JavaScript might look like this. Okay, that is cool. Okay, most of the time this is good because if car isn't a value that is exported from dot slash car, we will get a runtime error. Okay, but it does add a layer of complexity for certain edge cases. For example, notice there is no statement like import dot slash car. The import was dropped entirely. That actually makes a difference for modules that have side effects or no. TypeScript. A TypeScript's emit strategy for JavaScript also has another few layers of complexity. Import Elysian isn't always just driven by how an import is used. It often consults how a value is declared as well. So it is not always clear whether code like the following should be preserved or dropped. If car is declared with something like a class, then it can be preserved in the resulting JavaScript file. But if car is only declared as a type alias or interface, then JavaScript file shouldn't export car at all, while TypeScript might be able to make these emit decisions based on information from across files, and not every compiler can. The type modifier on imports and exports helps with these situations a bit. We can make it explicit whether an import or export is only being used for type analysis and can be dropped entirely in JavaScript file by using the type modifier. Import type all as car from this. Import type car, export type car. Okay, let's use type there, then maybe we won't get some error. Okay, error is gone. That is cool. Type modifiers are not quite useful on their own by default. Module module Elysian will, what is this thing by the way? Is the omission of slurring of shit. It is an English word.
Key aspects of elision.
Elision, sound detection. Hmm. Okay, it is some acoustic thing. Webster dictionary. Elision will still drop imports and nothing forces you to make the distinction between types and plain imports and exports. So TypeScript has the flag import not used as values to make sure you have the type modifier. Okay, so the thing it turns out is this. When we do not have this type thing here, yo, wait, lol, are you trying to use WebDev as a graphics library like STL or something? Just to make lines. We just need lines. I think this project might be better suited for our graphics library, not a web development. Web development because I can just send a static link to anyone and they can just like see the website. So that is cool. That's why I'm making this as a web development thing. You could have tried to make your portfolio website or something. Yeah, I guess a portfolio I won't make on the stream. I don't know, but yeah. Or maybe something like that, create a new component there, store in that. At least that is the convention. I have a component there and it is in that. I was thinking of using struct, but yeah, I guess class or interface might be better. Wait, struct, we do not, wait, this is a interface. This is not a struct. This is a interface. We need a interface there. Why two angles? And if you are saying the number of branches, then you cannot just do, can't you just do 2 pi divided by n where n is branches? No. And no, I also need a base angle because I do not want the whole thing to be like completely symmetrical. If there is no base angle, then there everything would be completely symmetrical. Where n is branches, since all the branches would be at equal angle in tree like fig. Okay, but we also have a baseline, right? If I have this endpoint and I need to make, let's say, two lines from this place and the total angle is 360, 360 by 2 would be 180. So 180, right? So if one branch, so there will be an angle of 180 between those two branches. So if this is my base, then one branch would go here. This is 180 and the next branch would be 180 from this side, which is just goes back on the parent. So not a very good thing. That is why I'm doing number of branches plus one, in which case this would be 360 by 3, 120. So for 120, let's say, I guess this is about 120, 120 from here, and then this is about 120, and this looks much better for two branches. This looks much better. Okay, and here the thing is that when we do imports, if the thing that we are importing is a type, then when the code is being converted from TypeScript to JavaScript, the source file, which is exporting the thing, this thing has no like representation in JavaScript. So this whole piece of code will be removed in JavaScript and nothing would be exported. Therefore, if TypeScript, if the transpiler keeps this line in the JavaScript code, there would be error because this file is no longer exporting anything because this is our interface and this will be removed from the JavaScript. Therefore, TypeScript might not know what to do with this line to keep this in the JavaScript file or not. So if we say type, then TypeScript knows to remove this line and yeah, TypeScript will remove this thing. Okay, and yeah, type DNA, this will return a list of lines. Yep. Let's say line.ts. Export line interface line, which is line. Yes, line. X1 is a number, Y1 is a number, X2 is a number, and Y2 is a number, which is being exported, which is cool. Okay. And then this function is how do I tell the how to specify return type in TypeScript. Okay, right here. Okay, and from this import DNA and also import type line from this place, and here say we will return a list of lines. Is this how we say a list of line? No, I guess. Line is declared, but its value is never read. Binding, wait, line is not a binding. DNA is declared, okay, that is fine. A function whose declared type is neither undefined must have a written value. Yes. Yes. How to specify a list in PS TypeScript. Yes. Okay. Number and then list. Yes, that is what I did the first time, but it didn't work. And yeah, it is working. So that is cool. Okay. A response is a line like this, which is initially empty. An element access extension should take an argument. At the end, return res. Okay. And now depending on the DNA, we will return the final thing, which is just going to be a list of lines. Okay, that is crazy. And do we need to give some other thing? We have to decide. Yeah, we will have to make few more things. What is going to be the size of this box in which we are making this whole thing so that our figure does not go out of proportions, out of this display area. Hmm. 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 Okay, we can think about that later. Let's first of all just make something that can make these things, these lines. Let's say let res dot append or push a line where x1 is 10, y1 is 10, and x2 is 100, and y2 is 100. DNA is not being used. Let's say console.log dna dot layers happy. Okay, so this is working in some way. SVG, let's have our own little DNA app. We will pass the DNA to the make make function. Yes, we will pass the DNA to the make function. This will take DNA type is here. Okay. This will take in DNA, and then this will call in the make svg. Let lines equal to make svg with this for this DNA, and here svg svg for en lines. Shit, map lines dot map That is the first argument, and the second would be the function. What is the interface for this map function? Dot map callback function. Okay, I am passing in the callback function. Value index the whole array. Okay, e dot, yes, okay. This has the lines. Make a line in SVG. It was a ChatGPT here. Line, and this is what we have: x1, x2, x1, y1, x2, y2, stroke, and width. Return for each of this line. Line x1, x1. The value is e dot x1. That works. And y1, e dot y1, x2, e dot x2, and y2, e dot y2. And stroke of genius, stroke black, double quotes. And width, stroke width. Stroke width 1. Something seems off, but shit, yes, something does seem off. And substitute all of these things with this globally. W is capital in width. Okay, that might just work. Okay, this takes in DNA, calls the line function, which returns lines and works with them. Okay, if lines dot uh, okay, just this, yep, and yep, this is what is returned. And make to the make function, we have to pass in some DNA. Let's make a DNA sample. Oops, DNA type DNA. Where these are the things. Copy, right? And here substitute number with 1. Cannot find name DNA. We can import type DNA. DNA is declared, but value is never used. That is fine. Make DNA DNA equals DNA. Wait, what? Huh? Type DNA true and false. No, DNA is not like shit. Okay, shit. This has to be specified like this. Did you mean DNA? DNA is declared, but its value is never read. Hmm. DNA is declared, but its value is never read. We are saying here that this thing should be DNA. How to make a React component take in input, how to specify type of React component input. How to specify type for React component input. Hello. Yes, after a long time. Uh, Relearning React. That is renaming. Uh, Not type declaration. That is type declaration. Wait, shit. I don't get Zorwin. Shit, Zorwin is a byte Zorwin. Something new. Props this and my component props and this props dot title. Yes, this is what we were doing before. DNA dot title. Uh, Pass in the whole DNA. Yes, it does work pretty cool, but we are getting error here somehow. Okay, let's change this to props. We'll have something which will be of type DNA, and here we'll say props.dna. Yes, that looks better. Yes, DNA is of type DNA. Yeah. Okay, everything seems set. Main function is has a like test DNA. It is calling the make function, and make function takes in DNA, calls in the line function to convert from DNA to SVG, and it is rendering this SVG. And shit, we have to tell this SVG the size. Yep, like this. Width, height, view box. View box is something. Wait, view box. Shit, where it starts, I think. Start here and end here. View box. That is cool. X, Y, X, Y. Start and end. And it starts from top left, I suppose. Okay, and we can also make a separate component for this, a component that takes in these lines and makes a SVG, renders a SVG. So width 200, not like that, 200, and height 200, let's say, and view box 0, 0, 200, 200. Okay, and now it might actually work. Localhost, nope, website is already running, but we don't see anything. Let's increase the width. Okay, nothing. What if we also say h1 hello there? Okay, we do see hello there, but we don't see this. Okay, width, height, and view box is evolution right here. You Rest language from original documentation. Wait, you are learning Rust language? Okay, that is not type declaration. That is renaming DNA to DNA. Wait, that is That is type declaration. I think here, right? Here I'm saying DNA is of type DNA, and DNA, this capital DNA, is a interface here, which has all of these values and all of them are numbers. DNA, we are God, we are making DNA. That is DNA. I think you don't check message. Shit, my bad. Wait, you are learning Rust from original documentation from props one is type declaration. Yes, this is specifying saying that DNA is of type capital DNA, right? Right. Rustilang is you can learn from the book. The book is cool and it is just said called the book to make my CV more faster and reduce the delay. That is my I'm using Rust. Mm, Shit. Wait, this is not renaming. Wait, let's see. Let me copy the whole thing. Yep, yes. Here I have a React component. Wait. Here I have a React component and I have used the term shit DNA. DNA is this renaming. I mean, I might be wrong. I don't know. This to this, or is it saying that DNA is of type DNA? Short answer, it is a type annotation, not renaming. Yes, that's what I meant. Remove props from there. Fun. DNA keeps it like this. Wait, yes, keep it like this. Shit, yes. I had when I didn't have props there, there was some error. Yes, this DNA is declared. Okay, this is renaming. This is renaming. Okay, shit, my bad. This is renaming. What about this? What about this? This is renaming. This does something different, and yes, this time you are renaming. My bad. This was renaming. Yes, it is renaming. There is a Rust with open CV library, but not gonna lie, Rust is way too complex. I don't even know C++ and directly jumped to Rust. Bro is pro. Not gonna lie, bro is pro. Bro knows renaming. Wait, Rust is complex, but more than complex, I would say Rust is more different than other languages. That is why it seems more difficult. But once you are more familiar with it, it is just yeah, it is fine. What this really means, yes, syntactically or semantically, this is JavaScript deconstructing with renaming. Okay, take props.dna, bind it to a local variable. Okay, it is equivalent to this. That makes sense. That makes sense. Yes. So this is renaming. This is renaming. My bad. Props. Just like this. But now here we do not see the line. The line is not here somehow. Mm, let's add line, like custom hard-coded line x1. Wait, shit. I guess this is not the right place to. Yes, shit. Of course, we are not seeing a line. This is not the place to add these things. Now we will probably see a line here. Yes, let's go. Let's go. We can make lines. We can make lines. That is cool. JavaScript is shit language for such nuances. Just hate it. Shit. I guess we sometimes have to hate work with things we hate. No variable is mutable. No variable is mutable unless you explicitly say, I want this variable to be mutable. Is Rust and mostly our user input are strings. I can't even add two numbers directly. I have to write 8 or 9 lines of code to do that. I'm scared of web development. I don't know why. Just don't be scared. Something a Viking once said. Yeah. Nothing is. And about the memory allocation, not the memory allocation, but the borrow checker checks for things. If you have, there are references. There is a mutable reference. There is immutable reference. When you have a, you can only have one mutable reference at a time, and when you have one mutable reference, you cannot have any number of immutable references. But when you have immutable references, you can have any number of immutable references and pass them anywhere, wherever you want. Yeah, Rust is a lot of things. Web3 dev, I am so confused. Yeah, Web3 is something else. DevOps, there is something borrowing type thing. Yes, borrow checker. There is in the Rust compiler a separate module. Wait, is Rust open source? Yes, shit, Rust is open source. I guess Rust. Then, so yeah, in the Rust compiler, there is, yes, membership. Wait, membership? In the Rust compiler, there is a separate, like smaller module, you could say, a simple function or a program which checks all of these borrowing rules, and it is called the borrow checker. And I don't know, I think we might be able to find it here. Borrow checker, maybe, I don't know. They are using GCC, docs, CI, build helper, it might be in build helper, source. Okay, if we do actually find borrow checker, that would be cool. Drop bomb. Why do they have stuff named with bombs and stuff? Hmm. Cargo.toml. Hmm. Rust is written in Rust. That is crazy. Tools. Build manifest. Yeah, there must be borrow checker somewhere. Rust. Rust formatter. FMT. Clipper. Build manifest. Checksum. Checksum. You can go there. Maybe search for borrow. Share. I think this is it. In Rust, it is common to provide different representations of a type for different use cases. For instance, storage local. Okay, okay. Borrow, trade. Yes, shit. Trade is something in C++ also. Yes. Yeah, there must be a separate smaller module which checks all of these rules, and it is called borrow checker. Yes, he's always says Web3 DevOps, etc. I don't know. Yes, yes, Web3 DevOps. He has courses on those things. It is recommended to download GCC. It uses GCC. GCC, it uses LLVM. Rust uses LLVM internally. LLVM, yep. And GCC is here. Yeah. Rust Lang GCC, their own version of GCC. Okay, back to evolution. We do have evolution here, and let's change this SVG. We can change shit. Let's yes, we will remove this white SVG, white SVG, and let's put this image, our first evolution organism, as the SVG. That would be cool. So how? Just copy this, take to some safe place, screenshot, and we'll make a SVG out of this thing. I think maybe we can just use it directly without changing. No, okay, we have to look at what the format is for this. Yeah, and I see a lot of guys giving Harkirat course for free. Shit. Like you can just wait, why is Epic open? You can just go and take his course for free. That is not something that he would like. He now also has a college, and shit, he just launched a new course, I think for AI, learn React. Yeah. Okay. Uh, that photo, the screenshot is in my Finder, but I do not want to open my Finder just like this. Let me hide the screen just for a minute. Yep, you have that. Okay, shit. Yep, okay, cool. You have the course. Okay, bro. Here is the image. We are going to use this. Right. The format is PNG. Yes, we can use PNG, I think. Evolution. And why do we have this random thing? Wait, what is RMRD? I messed up. In index.html, but before that, let's rename this to shit. Is Let's rename this to Adam, because like this is the first organism. Adam.png, and copy from desktop Adam.png to this place. Not this, move Adam to public domain index.html, and here instead of svg we have png called adam.png, and this might just work, or maybe not. It is not working. Okay, maybe stop, rerun. Localhost Hmm. Hmm. Index.html. Maybe the browser is using the same SVG, like maybe the browser has stored the SVG somewhere in cache, and that is why it is not updating this this photo at the top. Hmm, 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 hmm. We do have Adam here. Let's delete white. PNG is here. Stop. Now go to localhost 73. Okay. npm run dev localhost 73. Okay. Yes, shit. Browser is storing that thing somewhere. Application memory. Nope. Application session storage. Localhost theme dark extension storage dark mode. Browser things. Extensions are here. Cache storage buckets. Cookies. No, we do not have cookies. Yes, we do not. Storage. Wait, we can have maximum 1.5 GB of storage, around 1.5 GB. That is shit, not 1047 GB, 147 GB. That is a lot of storage a website can use. Shit, that is a lot of storage. Cache storage, no. Shit, let me use Safari, maybe. Localhost 5173. And shit, Safari does not have these little icons at the top. Okay. I do not have any other browser to make this work. Nope, my bad. Telegram on top? Shit, the whole bundle. Telegram on top, yes. Russian websites. Nope. Yeah. I guess it will just update later. Okay, so we are able to make lines. Now we have to make the correct lines. Yes. For which we have to update this function. dna.layers update print dna.layers. I think we will have something in the console. Yes, we do have one, which is correct. Now, and let's also make a component which prints svg. Yeah, print svg g dot tsx. Yep. Export print svg. Cannot find. It is a constant. And what does this thing take? This thing takes in lines a list of lines, and returns SVG. Let's also take the height and the width of the SVG. Props lines, a list of lines, and width a number, and height is also a number. Cool. Okay. Okay, lines is nothing. It is called line. Okay, and here we have width, which is props dot width, or we can destructure the whole thing. Here, const lines, uh, width, height equals. I think that is correct. Yes, that is correct. Width, and here given the height is height, and view box. View box is 0. Wait, shit, shit. View box. Ah, shit. Okay. View box would be given, not given by this function, but by some other function which is calling this component. Yes. Shit. So with all of this, we also need to have x, which is a number, and y, which is going to be a number. And in view box, we will have plus x plus, can we, I think we can do this, plus y plus space, or how to format a string in JavaScript. How to format a string in JS. This looks much better. Shit, not this. Shit. Okay, somehow I cannot print this backtick symbol. Okay, here, first thing is x, then space, then y, then space, then x plus width, space, y plus height. Okay, and now for lines, for which we can just copy paste this like that. Cool. No, not like that. Shit, no. Uh, Shit, I printed this thing where just from where I copied it. That is stupid. Print SVG, Yes. Okay. Yes, yes. Yep. So this will work. Print SVG will work, and this function will call print SVG helper make yes, and also print SVG. This wants some arguments. One is lines, which is just lines, and height, let's say 200, width, let's say 300, and x, let's say we will begin at 100, and y is also 100. And do we have some evolution? We do not have any evolution. So print SVG is not working properly. Yes, of course it is not working properly. Wait, no, it should work properly. Things seem fine. Yes, it should work properly. What is it that we are giving? Map, yes, map, make SVG. Make SVG is returning a random line. So this should be working. Print SVG is taking that line and printing a line. Lines.map, yes. SVG, let's see if we can print something else. H1, hello there, second. Yes, hello there, second is there. Shit, hello. Yep, not only Harkat, they have code with Harry, Chayar code, and more coders courses too. Shit. Uh, Free media, heck yeah. By the way, I have to ask something. Should I go with macOS, Windows for AI ML? Wait, operating system, Mac or Windows? Wait, the question I guess is not between the operating system. Operating system, you should go with Linux, not with any of these. But yeah, you have to decide whether you want M1 chip, which is very cool. The Apple hardware is for the laptop is pretty cool, but you cannot change anything. You cannot have Linux on this machine, which is a very downside, very big downside. M4 versus, well, of course, if you are like just comparing the GPU, then RTX 5050 is much better because it is a dedicated GPU and M4 is a normal processor for a phone, for a laptop. So yeah, you should go with RTX and not M4. M4 is not a GPU thing. It just has a like small GPU with M4. Apple M4 number of GPU cores. It is very small. Look at this. Yeah, 8 to 10 GPU cores. So, and RTX 50 number of GPU cores. 2560. So, and this has 8 or 10 GPU cores. But like individually, these GPU cores are much better. One of this GPU core is better than one of this GPU core, CUDA core. But Yeah, this is 8 or 10 at maximum, and these are 2564. So yeah, I guess RTX 5050 wins the thing. And hello, I gave the last contest. Like I did two questions. What is the plan for this stream? Making inventing evolution. This website we are creating, we have created DNA. Like this is how we are defining DNA. And given this DNA, we are right now creating a React component which takes in DNA and makes an organism. And this is an example of how an organism is going to look like at the end. And right now we are using SVG for that organism. For that organism. Sure, let's see how it goes. Can you use Rust for? I would say no. You can, but you should not, because laptops are expensive and because of the RAM. Yes, RAM, you cannot update RAM in Mac. That is also one downside. But my laptop is M1 and has 8 GB RAM, but I do not see any like lack of performance. Works fine for me. 8 GB RAM. Wait, for this one, there was a book by Richard Dawkins. Wow. The Blind Watchmaker, one of the best books I have ever read. The Blind Watchmaker. This one of the best books which I really have here. Where is OBS? Um, yeah, The Blind Watchmaker. This is literally one of the best books on evolution. And yeah, you can read this. It is pretty cool. Hello there, second. It is working. But we do not see the SVG, which is not very good. Maybe height with everything else is fine, but maybe this is not fine. Copy const sv something equals this console.log sv. Let's see how it is. And instead of this, delete, put st, and what do we see in st? This is correct. Let's use 0 for the base x and y places. Yeah. For b, let's use. Okay. Yes, it is working. And shit, look at this. 0 does not mean 0 with respect to the window. 0, x and y is starting from this point. That is something. Sh- Y 10, add these two things side by side. That would be much better. Okay, shit, why is X making this thing go back in left? Go in the left direction. That is strange. Shit, it is moving in the left direction somehow. Why is decreasing the height of this final thing? Uh, X plus width and y plus height, x plus width. And I think it has to, I guess I do not understand how viewport works. What are these numbers in view box? Okay. Due to RAM and storage, laptops are expensive now. Yes, because the AI people are buying all of the RAM, and there is only one company that makes chips and stuff, and only one company that makes the machines, which makes the chips. Yes, ASML, I think is the name. ASM? Yes, ASML is the company that makes the chips, that makes the machine which makes the chips, and the chips are made by TSMC, Taiwanese semiconductor company or something. And yeah, prices are high. It defines the okay view box. It is not about pixels. It is not about size on a screen. It is not a magic scaling spell. Let me check. Is the phone charging? The phone is not charging. Just one sec. I guess now, yep, cool. It defines the internal mathematical world of SVG. The four numbers, minimum x, minimum y, width and height, width and height of the coordinate space, maximum height of the coordinate space, and maximum height width of the coordinate space. Okay, okay. Y coordinate of the top left. Okay, use the top left as the origin. Okay, x coordinate of the top left origin. Okay, this should be the height and width of the whole thing, and this says where to place x y coordinate of the top left and x coordinate of the top left origin. So we will use okay, we have two boxes. Um, let's say this first box. So first of all, we have these two numbers. These two numbers are telling us the size of our whole view box, the place in which our SVG is going to be, and these first two numbers are telling us that in this box or whatever size we have already specified, where the origin is going to be. Origin normally is on the top left, and we can switch it, and we can say let's start the origin from this point, from the middle, and this would be our thing. And yeah, more like 75% of our image would be outside our view box, and we won't be able to see it. So 0 0 makes sense in that case. So yeah, let's just go with 0 0. So shit, we don't need anything else. We don't need x and y. We just need height and width. Makes sense. Yep. These things are going to be 0 0, space, width, height. Yes, height and width. Delete, paste, remove ST, and yes, we are happy. Okay. Remove, make SVG. Make SVG is no, we will keep make SVG. We can remove this app.tsx. What is happening in app.tsx? It is fine. It is fine. We can remove this. Make tsx is, wait, there is some problem with this make make function. Okay, we are giving it x and y, which are not being asked for. Okay, make function takes in DNA, converts it into SVG, and calls the function which takes in the lines and makes the lines. Print SVG, we do not, yeah, everything is done for this function. We don't need anything else to do with this. Okay, make SVG. Yep, and this is now the main crux of the thing, the main thing. Now we have numbers. Now we have our DNA with these numbers, and it should lead to an organism. A list of lines. We have to convert these numbers into a list of lines. Yep, that is the thing now. A list of lines. Okay. A list of lines. Shit. Okay. And shit. But yes, a list of lines. A list of lines. But at the end, we have to convert the DNA into a list of lines. Okay. And also, we must scale the whole thing. Yes, we must also scale. Yeah, we must also scale the whole thing down so that, like, if if the final organism is too big, we just shrink it down and make a smaller, like fit it into a smaller space, fit it into a smaller space. Yep. For which, wait, we can just begin by taking the baseline. We can just like make a raw image, and then we can pass it on to a function, and that function will go through this whole thing, and it will shrink or it will expand the organism to fit into whatever height and width we specify. Yeah, so okay, we will have that, but for that we need a function that takes in a bunch of lines and tells us the height of that organism. Like, what is the height of the organism, or and not or and and yes, and what is the width of the organism, because yes, we need both of them to shrink and still maintain their relative proportions. We do not want the image to be like squishing or expanding only in one direction. Mhm. Okay, finding out the height of an organism. That will come later. First of all, let's just make the organism. Okay, okay. Let front line equals empty. Okay, and front dot push a line Shit, we have to give it x and y coordinates. Shit, and shit, x and y coordinates. Shit, yes. Yes. You did say that we will have to use coordinates like this. Yes, we will have to use coordinates like this, and we will have a function which translates coordinate from like from the case where origin is, we will be writing the lines as if the origin is in the middle of the screen. And yes, we will be writing lines as if the origin is on the middle of the screen, and then we will have a function which will shift the origin so that all the lines are created as if the origin is here. Okay, the first line would be 0, uh, would be DNA. Wait, uh, DNA. Yes, front dot push. Let's have this separately. Front dot push x1 is DNA dot length divided by 2, and y shit, x1 is 0, and y1 is DNA dot length by 2, and x2 is also 0, and DNA on y2 is negative DNA dot length by 2. Length does, I messed up the spelling of length in DNA. Length. Length by 2. Okay, that is our base line or our front. And yeah, let's just push this. Rest dot push front 0, and for int I equals 0, I is smaller than DNA dot layers and a plus plus. Let I equals 0, and I start from 1. Okay, let's also have the base quantities from the DNA. Let length, you'll have it separately. Length equals DNA dot, we will not change the DNA, makes sense. Yep. We have the length, and angle equals DNA dot angles. uh, and what other things do we have? Branch, angle, length, branch and thickness. Branches let DNA dot thickness. Okay, and here length y2 and negative length y2. Okay, okay, okay. Now front, we have our front and we have to cycle through all of the lines in the front and create new lines and update our front to be equal to that new thing. Okay, okay. Let new front equals empty. Length, yes, I think we should update length. Yes. Not let length plus equals dna dot del length for how to iterate through items in a list in GS. How to do that? For each, that is something we can do. For each, run this function or const this of this or normal for loop. We do not need the index, so off is fine. We will use off. For line of lines, fonts, line of not lines but of front, we have a line. Now we have to make new lines from this place. Uh, okay. We are at a endpoint and we have to create new lines. We have the base angle, we have the new length, right? We just have to use all of these variables. Yes, we just have to use all of these variables. Yeah. Thickness, how do we give back the thickness of a line? Yes. Shit. Let's not use the thickness. Yeah, we are changing DNA. Let's not use the thickness. Yeah, let's not use the thickness. Yeah, we maybe we can add thickness later on. Length, angle, and branches, and number of layers. These are the only four things that we have. Okay, let's change our DNA. Comment this out, and yep, thickness does not exist. Length, angle, and branch. Okay. New front will have new lines. Okay. Yep. For let j equals j 0, j is smaller than branches. Yes, j smaller than branch and j plus plus. We have the base angle. Angle space equals. Will should we use 2 pi or 2 into. If we have base point for a line And okay, if we have one line and we want to create another new line starting from this place, and we also have the angle here, how do we, and we also have the length of this line d, how do we know where this endpoint will go? Hmm. And we have both this starting and ending point for this line. This is known, and this is what we are trying to find, this point. We have the angle and the distance. Mm, let's use some trigonometry. Mm, okay, for acute angle like this, we know d, we know this point, let's say, and we know this point, we know this point. Wait, shit, if we know two, yes, shit, let's say we just know two lines, right? And we need to find out their angle. Their angle is, I think, y2 minus y1 upon x2 minus x1 for two lines. If we have two lines like this, their angle, or we can, since we are using a Cartesian plane, we can find the equation of this line, and right, we can find the equation of this line. Let's say this angle is not on the left but on the right, like this. Angle is not on the left but on the right, like this, and we can find the angle, this angle theta dash, and then this angle, and then this line. Yep. Hello. How's everything going on? After a long time, yes. Though I did give the last Code Forces contest, it was, I think, on 6. And yeah, yes. Shit, are you reacting to me using React? That is an overreaction. What you making? We are making a game of evolution. Like, uh, there was a book by Richard Dawkins, this one, The Blind Watchmaker, and in that book he made a program which simulates evolution. And yes, it just sounds very cool. And at the end, yeah, we will have a bunch of organisms, and in a generation we can choose some organisms which will go on to the next generation, produce more offsprings, and yeah, we will have at the end more complex shapes. That is what we are trying to do here. And this is our DNA. In our DNA, we have 7 numbers whose values are between 1 to 9. And this is an example organism which we created for some DNA. And yeah, it just sounds very cool. Yes, I saw yours. Stupid mistake while finding max in problem 2 and didn't try again. First one was cool. If on at least one is there at one of the ends, then Alice can win by removing all of the zeros. If there is at least one zero on Bob's chance, on his first chance, then Bob will win by choosing the whole list. That was cool. And the second question, second problem, not question, problems. Second problem, I forgot what was the second problem, but I guess it was also cool. Okay. New contest on 12. And for the third one, yeah, I was unable to do the third one. Yet another mix problem. Yes, shit, yes. For this, I just thought maybe there is always some way to remove all of the biggest numbers. And we know at the end that we will end up with, I think, how many integers? Yeah, we know that at the end we will end up with some certain number of integers, and we will always be able to remove all of the biggest integers. Think, wait. The final max is 2 for the third test case, n and k. Yes, yes, I guess we will end up with this many integers at the end, and we can always remove the bigger integers. Like we can remove 4, then we can remove this, and we will have 0 1 2 and 3. That is 4. Shit, we will have k minus 1 integers. Wait. This does not check out. Yep, we are supposed to have k minus 1 integers, not k integers. K minus 1, k minus 1, k minus 1. We can remove these two, we can remove this, and we will end up with 4 integers. Wait, even if we have 5 integers at the end, we can keep this and these and remove 4 and 1, and we will have 4 as the mix. Yeah, we will have k minus 1 integers at the end. Yeah, shit. We will have k minus 1 integers at the end and always remove the bigger ones. Wait, I didn't use break when we get mix. That the only thing I missed. That was so silly. Shit. Use the break when we get mix. I don't get that. I on I also got the same thought when I got the wrong answer. I just got out of idea and didn't try it. I should have checked my code again. Yep. 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 Like, yeah, we lose motivation. Yeah, so we are trying to make a evolution game. So that is cool. Okay, and now the current problem is geometry. I think our geometry should be good because space-time is geometry. Okay, we have one starting point and ending point. We know one angle like this, theta, and we also know the starting point of this line. We need to figure out the ending point of this line. That is the only thing that we need to figure out. This should not be very. Wait, shit. We can think of this since the height or distance of this line is fixed. We can think of this as a circle which is starting at this point, and from that we know the center of the circle. We know the center of the circle. We can find the equation of the circle and find the point which is at some certain distance here. Hmm. Yes, it is a circle. We can find, I think equation of a circle is something like x square plus y square equals r square, or maybe not. I think r square, this is not x square, r square, r is the radius. Hmm. Hmm. How to find point on a circle when given an angle. Trigonometry. But the thing is that we do not have any plane shed. Instead of circle, we should just use these lines. We can go to ChatGPT and ask for this exact case, but no, no, no. That is not we want. What we want to do. Wait, let's better state the problem. We have, let's say, S1, E1, and E2. We have these points and we have this angle. We have four things. We have three things. We have this. We need to figure out this. And first of all, yes, this is determinable. This is deterministic. There is no like room for error here. If all of these things, all these, this, this, and this quantities are fixed, then this point is also fixed. Okay, if we extend these lines like like this, we have this angle, we have this angle, yep, we have this angle. Shit, how do we find the line? Crazy. We, I am doing CP. Like at least I did one contest. Yeah, we will end up with like 0, 1, 2, 3, like in this array, or if there are duplicates, then we will, then it's will be mix of original array. Yes, not original. It depends on how many numbers we will have at the end, right? Yeah. I did one contest, the contest on Hello 2026. So is this like a new project or like some fork you were? No, this is a new project. My project. No, no, I have not retired. I'm back. Shit, I did not want to use that term, but yeah, I'm doing CP. If you want to work on some circle geometry, I have a really cool problem. Shit, please send the really cool problem. But why? Huh? Shit, no. Winnie VCVD, okay, bro, only do contests. Yes, contests, and like after the contest reading, and still CPHB competitive. Shit. CP hand. This is like the best book for competitive programming, at least for not for comprehensive things, but you can use this as an index to know what things there are. And yeah, I still haven't completed this book, and my goal would be just to complete this, and that is cool. I guess I can reach 2000 with this. Yes. And yes, our contest is like still on to reach 2000. Wait, shit. Problem as in a CP problem. Wait, not yet, not yet. I will take a screenshot with your name. Yeah, I'll do it. And this. How to find angle between two vector. Can we use vectors between two lines? Shit. That is some school stuff. Yes, this is what we. Hmm. Hmm. But we have points and not lines. A line is written like y equals mx plus c. This is a line. We do not have a line. We have a starting point and an ending point. Mhm. Y equals mx plus c. Y equals mx plus c. Do we convert this into a line and then work with lines, or there might be some direct way to like where we do not have to convert all of this into lines? Hmm, 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 hmm. This is the angle theta. And the thing is also that this angle could be acute angle, obtuse angle, or anything. Yes. So we might have a situation like this. We might have a situation like this. Hmm. Hmm. Here's starting point, ending point, two starting points. We are lines. Wait, shit. Shit. Yes, working with this in terms of lines is much better. Yes, because we can convert uh, this starting and ending point, which we do know, into a line, into an equation of a line in terms of in this form y equals mx plus c, and we can use this theta angle to find the other line, to find equation for the other line, and for that other line we already have one of its point and a distance. So what would be the point when we move this d distance into the direction of that line? Wait, we don't even need the direction. We just need the direction. We don't even need the exact. We don't need the exact equation of the line. We just need the direction, which is the slope. Shit, slope. Yes. Shit, yes, we can work with slopes. Yes, yes, we can work with the slopes, which is more like y equals mx, where m is the slope. M equals y by x. Yes, we can work with slopes. Okay, we have one line. We have another line. We have angle theta. Okay, what we do know is this angle, let's say phi. Wait, this is not phi. This is like from Spider-Man, and we have this, and can we have the equation for this? We just need this slope. We don't need anything else. We just need this. Let's say theta dash, nothing else. We can do this. This would be 90. This we can know this. This would be 90 minus phi. This angle would be 90 minus phi. This angle is 90, and the whole is theta. So theta equals 90 minus phi, which is this angle, plus 90 plus this theta dash that we are looking for. So theta dash equals theta minus 180, but yes, this is like wrong. Shit, this is phi. This is phi. No, yes, this is this thing, but this is wrong because again, this line can be anywhere. So in this case, we have something like this, but we could also have something like this, in which case if we were to do this exact same thing, let's see what will happen. And yes, the angle is always on the right, so theta is always on the right. This would be this phi, this would be 90 minus phi, and yeah, everything breaks apart. Now theta is no longer the sum, but it is now the kind of the difference. Yep. Wait, let's just move forward with this. What we need is this angle, theta dash. Theta dash, eh, theta equals theta dash plus this little angle here, which is this little angle is equal to 90, which is this whole thing, minus this angle. So 90 minus this angle. This angle is itself 90 minus shit. Isn't this a property where if this is parallel with this angle equal to this angle? Yes. So this angle is phi. So yeah, theta is 90 plus phi, not this. So yeah, in which case theta dash would be theta minus phi. And yes, so yeah, this formula is wrong. So we, instead of generalizing the formula, we can use two if conditions, and the if conditions would depend, yes, if condition would depend on two things. First of all, where this line is and where this line is. What is the angle of slope of this line and slope of this line, right? So if this line, first line, is on the right, then we will use this formula, and if first line is on the left, then we will use this second formula. And does the answer depend on where this line is? Like if this line is here, 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 where will, the question is now, will this formula always work if this first starting line is to the right? That is the question. Wait, is, wait, Asbros share. Wait, huh. I'm trying to calculate. Okay, we have a line, right? I have the starting point and the ending point of a line, and I have a angle. I have some angle theta, and with this angle, I have to create another line at the end point of this first line, and I have the length of this second line. So what we need to find is the end point of this second line, which is to be created at the end point of this first line. I think we should work with slopes. Slopes seem to be the way to go. So literally one contest is barely doing and rating lie down and regret why I started shared. That is like life in a nutshell. Facts. And performance in contest matters, and there is not much progress. So wait, huh? How much rating just practice and performance contest? Performance is the thing that matters. Shit, this formula is not general. This formula will not always work just because this line is on the right. Yep. Wait, can we make a triangle out of this? Like, since this angle is, one angle is defined, this length d1 is defined, this length d2 is defined. Shit, yes, we can make a triangle out of this. We can make a triangle out of this, and using these things, shit, if this is d1 and d2, then the area of the triangle would be d1 into d2 into sine theta. I think, yes, half, because this is our triangle, this is the angle d1 d2, d1 d2, let's say like this. And yes, if we are creating a perpendicular line from this to this, and sine theta d1 would give us this, which is the height. Yeah, that would work. Cos sine is like this, right? This is the 90 place. So after 90, sine is symmetrical. What is sine 90 minus theta? Yeah, sine 90 plus theta. If we have some value, we shift it forward by, shit, it is theta. No, 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 shit, no, it is not theta. Let's say we are close to this point and we increase by 90, we will be close to the end. Right, is it 1 minus sine 90? Sine theta. 90 minus theta. Shit. Cos theta. Uh, yeah, the point is, I think this formula is correct. This formula for the area of a triangle, if we have two lengths and an angle. Yep. So we can calculate the area of this triangle, and then I think we can calculate the area of this triangle using points also. There is, I think, a formula in which if we give it the points, these endpoints of a triangle, we can calculate the area. Then we can use that formula and plug in the value we got from this formula and find out that point which we do not know. So area of a given 3 points. Okay. Modulus. But this is just one equation, and there are two unknowns that we do not know, which is, let's say, x3 and y3 of a triangle given angle and two sides. Given angle and two sides, yes. Sine theta by 2 sine a into b and sine. Yes. Wait, gamma 3 degree. Okay, so the formula is correct. Mm, you might be able to use this with these two formulas together. This one and find the answer. You need slope. Slope. Yep. Will the right or left thing matter if we have the angle, like where the angle is from? If the angle is from the right, like angle is like this or like this. I mean, we can choose it whatever we want. It is up to us. We are the makers. We are gods in this case, quite literally, because we are creating DNA. Slope. For slope, we can use slope. And yes, well, for this area thing, at the end we need to find out two things: x3, one x coordinate and one y coordinate. But yeah, when one shit, of course this will not work. Shit, yes, 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 this formula will not work, the triangle one, because this formula takes in 3 points, right? And we are saying that out of those three, two are fixed and we already know the area. Then the third point could be, we can take, let's say, a line which is parallel to this base, and this third point could literally be anywhere on this line and would still give the same area, because like base is same and height is same for all the points on this line. So yeah, shit, no, that is not going to be the answer. Yeah, at the, yes, this formula will give us a line, not a point. This one will give us a line and not a point. We need one point on that line. Shit. There is a formula. Uh, when there is a formula to calculate distance between two points, and for the second point, we can use a line. One point is already fixed. Shit, yes, this will work. This will work. Yep, this will work. This will work. This will work. This will work. Yes. Yep, this will work. This will work. This will work. This will work. Angle space equals uh, uh, 2 pi or 3 6. Yeah, let's use 2 pi or pi in GS, not pie chart, pi math pi in GS, math dot pi. Okay, 2 pi minus the base angle. Shit, in that case, the base angle value would be from 1 to 9. From 1 to 9, which is not good. Which is not good. Let's use, instead of pi, we will use 360. 360 minus angle, and angle value would be, all the other values in the DNA would be from 1 to 9, and angle 1 would be from 0 to 360. Yep, not 0 to 360 at some point, like, yeah, we cannot give all the values. 0 to 9, we can map 0 to 9 onto 360 degrees, and let's say we'll cut this whole thing into 10. 2 3 4 5 6 7 8, and there are 1 2 3 4 5 6 7 8 9 10 lines. Yeah, let's say, yeah, we'll do that. This depends on sign in case. Does it return us the value in terms of pi? Yes, this uses pi, so we will not use 360, we will use pi. 2 into math dot pi minus, let's convert the base angle from 1 to 9, divided by 10 into 2 into math dot pi. Seems cool. Angle is declared, but its value is never used. So is branch. No, branch is used. Minus angle. Okay. Minus angle. We have the, yes, remaining place, and this whole thing divided by branch plus 1. This whole thing divided by branch plus 1. Cool. Okay. Okay. And let base angle equals 0. No, let base angles equal angle space. Okay, base angle equal angle space. Now we do have all the points. PT1 point, or like ST1 starting point 1 is line dot x1 and line dot y1, and end point 1 is line dot x2 and line dot y2, and angle between these two lines is base angle. Base angle plus j into angle space. Okay, and distance d1 would be distance between 2 points, x2 square minus x2 minus x1 square plus y2 minus y1 square whole under root. This might be more complicated. Maybe slope idea was better using the slope. It is a fact. Right. Right. Will the right? No. I searched for the formula hint. It need sine and cos. So maybe you are going in the right direction. So your problem is kind of like find a point 5 units at, yes. Um, okay, if from this, not this, I have 2 points instead of one, because with 1 point, how do you specify an angle, right? You need 2 points to specify in which angle. So let's use the area thing. Const area would be, let's also use the distances. Const d1 equals the distance, which would be the length, the previous length. Length minus, is length minus dna dot del length. Const d2 is just length. Okay, and const area equals math dot sine, math dot sine of base angle into j into angle space. This thing multiplied by d1 into d2. Okay, we have the area. Now we need the, we will use this equation to find a line. We will use this equation to find a line. We have area equals half x1, my writing is very bad, x1 y2, this is modulus. What we don't know is y3 and x3, y2 minus y3, y3 minus y1, and y1 minus y2. Yeah. y2 minus y3 plus x2, y3 minus y1 plus x3 bracket y1 minus not plus minus y2 modulus. So 2 into area equals modulus. This thing is unknown. This is unknown and this is unknown. Okay. X3 y1 minus y2. This will be a constant. We will know this. Let's um no, this is what we do not know. Let's put y3 at some place. Y3. This will have minus x1 and plus x2. Yep, we have y3. Okay, and what is remaining? Plus x1 y2 minus y1 x2 modulus. And among these things, we do not know this number and we do not know this number, and this will lead to a equation. Okay, this will lead to a equation, and we also have a modulus here. How do we remove a modulus from an equation? It depends on the equation, I think. So at the end, we need to convert this thing into something like y equals mx plus c. Yes, this is what we want at the end out of this equation, where we are saying, let's say x3 is x and y3 is y. We need to find m and we need to find c out of this equation. But there is a modulus here. There is a modulus here. How to remove a modulus in maths? Expression this or this, we have something like this. Identify the expression. For this, the expression is this. Okay, case 2, expression is positive. We do not know what the expression is. Shit. Oh shit. We need to specify cases. If x is greater than 3, there will be 3 cases here. This equals x if x is greater than 0, and yeah, but we do not know the value inside the expression because it has variables. Shit. Modulus is messing things up. Modulus is messing things up. It yeah, in this you need to update the angle, like in the above example, 30 degree angle is from x, so you need to calculate the angle with respect to x-axis as well. Then you can apply formula with respect to base. Why this area? Because I ended up, there are two formulas for calculating area. One is, like, since we have two lines, we do not have whole lines like y equals mx. We do not have that. We have one starting point and ending point for each line. So I thought maybe we can convert this into a triangle, and there are two formulas for area of a triangle. One is using two length of two sides, and an angle, which is this formula, half d1 d2 into sine theta. And there is also this formula, this one, when we have all of these points. So when we find out area using this formula and put it in this formula, we will get a equation for a line. For a line, yes, we will get a equation for a line like this, right? And we need to figure out where the final point is going to be on this final line. And now we can look at the problem like this. We have a line, we have a point, and this point needs to have a certain distance d2 from this line, and wherever this d2 distance lands, that is going to be our final point. But shit, because we will get the same distance d2 on completely opposite side of that line also. So shit, there is some ambiguity, my bad. You have 2 points for starting line, right? Yes, we have 2 points, starting point and the ending point. Shit, it has been like 1 hour um, uh, since we have been pondering on this question. Mm, no, not ChatGPT. And yep, it has been 3 hours. I like have to take a little break, and I guess we can start tomorrow from this same point. And yeah, I will figure out today itself how to find this ending point. And when that is done, we would have a way we would have a way to make an organism like this one. If we have its DNA, given the DNA, we will have a React component. Yes, tomorrow we will have a React component which takes in DNA for an organism and makes that organism on the screen. And then we will have, wait, then it is not like very complex, because we need to add random mutation, which is, I guess, simple. We will just look up some formula, or we can create our own version for random mutations, and the user would be the one who is doing the natural selection. Angle for that line from x. X is yes, and then add, shit. Okay, shit. Shit. Okay. So this is our Cartesian plane. We have this starting line, right? Original line. We can calculate this angle, right? Let's say theta, and we have another angle. Let's say phi, or like theta dash. We can extend this, and we have this. We need to figure out this thing, and this would be, I think, minus theta plus theta dash would be equal to this angle, minus theta plus theta dash, because if theta dash is 0, then this line is going in this direction, backward direction. And yeah, and for every increase in, yeah, so minus theta, this direction is minus theta, and whenever we increase theta dash, we are increasing in this positive circle direction. So shit, we have this angle which is y equals m x, and shit, this angle is just m. We have m. This angle is equal to x, y2 minus y1 upon y2 minus y1 upon x2 minus x1 for this second line. Shit. Okay, bro has it. Will we have titans as well? Uh, well, we do. We are saying that all of these values in the DNA can take can only be from 1 to 9, so that might be some indication, right? The number 9 is there, so we might have titans, 9 of them. We can do this right now. Share. Okay, that is crazy. We don't need area or anything. Okay, let's say const slope slope would be equal to, yep, this angle is theta dash. Yep, we have the angle theta dash and theta. If we can calculate theta, cons angle, wait, angle between, or between angle, between angle and first first angle would be line dot y2, line dot y2 minus line dot y1 divided by line dot x2 minus line dot x1, and then the slope would be minus of first angle plus between angle. That, not slope, but like second angle is a better term. Shade, we just have the slope. Okay, yes, we also have the distance. That is cool. That is cool. That is cool. So now, yes, we have the distance. Yes. Okay. Now what we have is a point, a distance, and an angle. And we should be able to figure out this second point, where it lands, right? Wait, distance into sine theta. Yeah, shit. Const x2 would be original x, which is line dot x2, plus math dot sine of this second angle, which is in terms of pi, which is in terms of pi. Yeah. Sine of second angle. Can we do this? Sine of second angle. Yep. Sine of second angle will give us the component. Wait, cos would give us the component in x direction. This thing multiplied by distance. Distance is length. Const y2 is line dot y2 plus math dot sine second angle into length. Okay, and this will be our new endpoint. Shit, we can add this to our front dot push x1. New front, we have to wait. Yes, we have to say that new front is a list of lines. X1 is has the value line dot x2, and y1 has the value line dot y2, and x2 is just wait x2 and y2. We can write them like this. Cool. We are able to at least figure out the next point. That is cool. And we will have titans. Don't worry. Okay. So what we are doing is, yep, we have created branches. We have added new lines onto the front for some layer. Yep, yep, yep. And here we will say front equals new front. Front will be equal to new front. Yep, and yeah, that should work. That should work. Front equals new front. Wait, that might add, that actually should work. Yep. Make SVG. Make SVG. Make SVG. Make SVG takes in DNA and works magic. Okay, this make function takes in a DNA. Yeah. Okay. App.txx. Our first uh, thickness is something that we do not have. Okay. Let's say our organism has 3 layers, one branch, one delta branch, angles, one delta angle increases by one. Should we have not done anything with delta angles? Yes, we have to also update angle. Yes, 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 yes. Yep. Front equals front, angle equal minimum of 9, or angle plus delta angle, angle plus DNA dot del angles. Gonna find uh, math dot min. Okay, we have updated the angle. Length is already being updated above, and branch equals math dot min, minimum of 9 dot branch plus DNA dot del branch. And now just this, we have to do the same thing here. Length plus length equals math dot minimum of 9, 9 or yep, 9 or length plus DNA dot del length. And we have to make some changes here with the starting point. Yep. Length, we have to specify how does 1 unit of length, how many pixels does 1 unit of length mean. So yeah, mm, const pixels per length equals, let's say, 10 or 20 is 20 and length into pixels per length. And okay, this is here, this is fine, but here instead of 9 we have to multiply by pixels per unit length, and here we cannot directly add, we have to multiply by pixels per unit length. And yep, so that is like actually correct. Okay. Okay. We also have changed the DNA, which is cool, which is cool, which is cool, which is cool. Here lines print svg. Okay, let's look at our masterpiece. Okay, this is our organism, which is something. Let's put them side by side. Okay, why do we just have this? Let's make change in the DNA and see if the organism is changing or not. Let's say, okay, no change. Number of layers has no effect. Somehow, let's change this to be 40. This is returning, yes. Print svg takes in lines and stuff. Okay, yeah, let's increase the height and everything. Height, let's say 1000, and width is also 1000. Yes, there needs to be a translation layer. These points, have been created as if, yeah, these points are different. Shit. Wait, we can change. Yes. Shit. We can change this. Yes, we can change this, the view box. Let's say 500 manually. Nope, it does not work. Shit. Uh, Shit. Ghosty is messed up. Yeah, cool. It's working. Okay, we have to have a translation layer, helper functions, translate chords dot ts. This thing takes in a point. Let's also have a, no, we will not have a point. Translation, translate chords. This, wait, do we need a function? Yes. Export const translate equals, this thing takes in a number x, which is a number, and y, which is a number, and width, which is a number, and height, which is a number, and returns a number. Wait, no, it will not return a number. It will return x, which is a number, and y, which is a number, an object. X is declared, but its value is never read. Shit. Do I have to say point? X. Shit. Yes. Interfaces, we will have to create a point interface. Shit. Point.ts export interface point x, a number, and y, a number, and update line to say start with a point and end point. This will like change other things. App.tsx, no change here. Here, yep. SVG, yes, there will be changes here. Yeah, start, whose value is x is 0 and y is length by 2, and n x is 0 and y is negative length by 2, except the semicolon part. Okay, line.x, yeah, these things don't exist. Dot end dot y and dot start dot y dot end dot this dot start dot x dot end dot x, not 2 but this, yep, and here dot end, and here, yeah, start whose value x value is line dot end dot x, line dot, wait, huh, y is missing, yes, y is right here, line dot end dot y, and end is x value x2 and y value y2. Okay, everything is cool, and the point of all of this was this, to paint this and say here we will take a point p of type point import type point, and we will also return point. Point, yes, let response of type point x 0 and y is 0. return res. Yep, and now the value should be, yep, wait, I'll just we can just say return x value is p dot x minus width by 2, and y value is p dot y minus height by 2. Width by 2, height by, shit, yes, no, 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 plus, plus, not minus, plus. And hopefully we do see something. Uh, Hello, Titans. Bro, have you used Helix? Helix? Helix patch? Helix. David Goggins had a Helix patch in his heart. Right? Heart. Helix. Okay. Double Helix. Okay. Editor. Helix is a editor. Nope, I have not used. Vim is the best. Wait. Helix. Postmodern shit. Postmodernism. Text editor, multiple selections, tree sitter integration, powerful code manipulation, language server support, built in Rust. I think Z is also built in Rust. Z is the editor, right? I'm not hallucinating. Yes, Rust. Helix postmodern editor, and okay, it is also in terminal. Terminal based. Okay, this person is not using relative line numbers. Yes, we you should use relative line numbers in Vim. Helix. So are you using Helix? Or maybe shit, this could have been a pun on the part, like we are creating evolution, inventing evolution. Okay, but the thing is, we do not see anything here. Shit. How to give border in SVG? Adding border in SVG. Circle, rectangle. Ah, rectangle. We can make a rectangle with the starting xy equal to 0. Should we are not calling the translate function? That is, yes, something. Make SVG components, print SVG. Yes, error makes sense. E dot x1 is nothing. E dot start dot x, E dot start dot y, E dot end dot x, and E dot end dot y. Do we see something? No. Okay, makes sense. We also have to translate. Required 3 is this width and height. Shade. Okay, yes, this thing will return something else. Okay. Uh, const start equals translate e dot width, e e dot start. Yes, e dot start, given the width and the height. end equals translate e dot end or dot end. Remove the translation from here. Cool. And instead of e dot, just use start and substitute e dot with literally nothing. Cool. Do we now see something? We see a single line. Hmm. Let's add rectangle x 0 y 0 width width the whole thing and height height. Shit. We do see something. Yo, let's go. We have a single line here. Let's change the width and height to be something else. Nope. Just came to know about this editor. Just that. Yep. Editors. Yes. Height is too much. Height is a bit too much. Just 500, 300. It's fine. Width is yeah. This is our SVG. And this is how our organism is looking like. Okay, we are not doing a good job being gods. Hmm. Something is wrong, but something is in the way. Wait. For const line of lines, let's print console.log line dot start and yeah, comma line dot end, or just print the lines, or better still console.log lines. Mhm. we just we just have a single line. Okay, so yeah, that is the problem. We are not. Shit, of course. Yes. Make a separate screen for this. Hello. Bro, what do you mean by inventing evolution? We are inventing evolution here. We're making titans. Yes. Sounds crazy? Yep. For real, for real. Shit. How do you know his real name? Okay, shit. I didn't. I thought a new person is here. Okay. Hello, Kakashi. Sam is coming. Shit. Winter is coming. Okay, the problem is after this point we have to add all of these lines from the front into our response. For const f of front this dot push f. Okay, Like we are, I think, actually cooking now. No, shit, no, no, we are not. Okay, that is something. And wait, why don't we have anything in layers? Okay, DNA dot layers. I think we do not have enough layers. Like we are in advent of code. Wait, we don't have enough layers. Where is our DNA? Yes, we do not have enough layers. Okay, let's see the magic now. Hopefully this works. Okay, let's increase the number of layers to 2. Okay, we have something. Let's increase the number of branches to 3. Number of layers to 3. Mm, delta to 0. This delta to 0. And mm, hmm, 7 layers. Hmm, hmm. Okay, yes, we have made progress. We have made some progress. Use fragment tag for multiple return elements. Wait, yes, that is fine. That is fine. We can use that. This error was not because of that. This error was because uh, when I'm iterating through lines here, where is it? Should we do not have this components print SVG? Yes. Here, when we are iterating through lines, here using this map function, we need to give each line a new ID. So like ID like this. If we do this, this will work. And yeah, we can just say, let's say, let x or let ID equals 0. And here we can say this equals ID. Okay, shit, ID should be a string. ID should, shit, okay. ID, and after returning each line or before ID plus equals ID plus equals 1. A little hack, and now I think we should not have like at least that. We have a lot of lines. NaNa, okay, okay. End point is NaNa, okay. Key props, ID. Key props, yeah, key. We need a key for everything, but yeah, we are just using random numbers for that, just like linear numbers from 1 to end. I mean, shit, you are a child and just learning basic dev stuff, and you guys are inventing evolution, and it is scaring the shit out of me. That feels so overwhelming. I don't know how will I do it. Wait, I mean, you are good at CP, and I mean, the major part is not how difficult this thing is. It is just you being scared. scared, so don't be scared. Everything, just guessing. Yes. Not you guys, only this. I, shit, I do not want to open up my history. Wait, let me first check and I will show you. Yes, it is fine. It is fine. You can look at it. Okay, and what am I trying to show? That I was looking up stupid, simple things. How to write interface in TypeScript, how to import interface, or this white, how to create a white project, React. Yeah, not I was not looking up how to create a new repository in GitHub, but yeah, how to create a white project and everything. So yes, just figure it out on the way. Yes, never show history. You were stuck at green. Shit, green means potential, right? It is pretty bad. Shit. I mean, yeah, you can grow. Grow only into study. This is just history from the stream, like past 3.5 hours. It should. It gives you auto suggestions. Suggestions here. What is S? Stellan, scars, guard, stack overflow, and some stuff. Shit. What? Yes. Okay. And so the problem is this thing. This uh second x2 y2. This is coming out to be nan, like NaN. That is not very good. Let's say 2 and branches is 2. Okay, let's see now. What do we see? Error. Each child should have a unique prop. Okay, so we did not fix that error. And nan, we should not have nan. Yeah, we do have nan, which is wrong. Wait, shit. What do we have in front? End of this line. There is a semantic mistake, meaning mistake. We want the new thing to spread out of the top and also the bottom. So front has this, but also let's say a second line. Mhm. Where these start and end points have like switched, flipped. Yeah, that looks good. Hmm. Okay, now shit. At least that looks better than anything we have had. Okay, we have 5 lines, which makes sense, which is like fine. Okay, nan. Why do we have nan? That does not make sense. Why do we have not a number? Why? Console.log x2 x2 comma y2. Let's see. Mm, okay, not a number. Shit. Okay, x2 and y2 are not a number. Let's see when we are losing this numberness. Second angle. Is second angle fine? Nope. Second angle is minus infinity somehow. Okay. First angle. First angle is also infinity or minus infinity. Between angle, that is some number. Okay, please, that is fine. G into angle space. Okay. Wait, between angle is too big? No, no, no. It is like half of 2 pi, which is pi. Yeah, it is a bit greater than pi, which makes sense. Yes. Wait, it should be smaller than pi, not bigger than pi. Okay, whatever. Okay. Between angle looks fine, but this thing is not. We have to convert this thing into shade x shade. Okay, okay, makes sense, makes sense. Because here the angle is 90. Shade, yes, angle in this case is 90. Okay, shade if line dot end dot x equals line dot start dot x, then in that case we will have first angle equal to 90, which is pi by 2, pi by 2, or 2.0, or 2, because pi I suppose would be floating point. Okay, and second angle, I think now things, shit, we have our creatures. Hello, we have our creatures. Yes, react. uh, Green means people. Yes, it does. It, like, green is like a tree that is sprouting. Yes. Okay, we have working. We are working. We are working. We actually are working. Let's change the DNA, increase the number of layers. Okay, and delta branches is 1. Okay, and let's have, okay, we have a bigger length now. Not too big. Okay, and angle, let's also change angle. Okay, that is okay. Or shit, why are all of them going in the same place? Wait, wait, wait. Okay, that is a lot of things. That is shit. That is some organism. Mhm. Let's make this 1,000 by 1,000. And yep, this is one of our own organism, one of our creation. Okay, let's decrease the number of layers. There are too many layers. Okay. No, we need symmetry. We need symmetry. Shit. Yes, we need symmetry. Angles. Del angle is 0. Even this is 0. Okay, I was hoping to get some symmetry, but no. Okay, there is symmetry. Got 3 layers. There is that is not symmetry. But okay, yeah, we do have something. We do have something. We can convert DNA to SVG and it is working. Yes, and we will continue tomorrow. Yep, this would be the end of today's stream. Damn, yes, it is working. Bromida bush, yes, burning bush. Take SS, we will add it in history book. Name him Bob. Shit, Bob. Bob with 7 layers of deepness. 6 layers. So that looks good. Uh, shit. I closed him. My bad. Okay. Yeah, that is. Mm, yes, that is something. There is a line of symmetry. So technically symmetric, just not in the axis you wanted. Yeah, I want more symmetry. Like in the y-axis. Symmetrical on the x-axis. Evolution images, something like this. Yeah, organisms like this. And yes, now since we have some way of making an organism, we can just update it, revise it, and make it much better. And for today, that will be the end of the stream. And thank you for being here. Bye.